Hello students, let us discuss the fifth module, sampling. Now sampling is very interesting topic and it is of great use especially when you are doing research or in your project works, right? So let us start with sampling and first let us try to understand what is the meaning of sampling. Being an engineering student, I suggest all of you to do sampling in detail. Whatever I am teaching, more than that, you need to go and study it in depth so that it will be very helpful for you when you do the projects and all. You should also learn the softwares connected to this. It will be of great use to you. Okay, so now let us understand what is the meaning of sampling. See, here we are talking about a one big large collection which is called the population. Okay, so there is a one big large collection which is called population. For example, if I say India, so it is a population. If I say, or if I take a name of any college, suppose New Horizon College of Engineering, so that is a population. Now what I am doing, whatever information of population is there, information means like if I am talking about mean, if I am talking about standard deviation, so these are called parameters. Okay. So these are called parameters of population. And the size of the population is represented by capital N. Now mean is represented by mu and standard deviation is generally represented by sigma and size is represented by N. Now what I am doing, I am taking a small subset of this population. Okay. That subset is called the sample. And the details of that sample, that is mean, which is represented by x bar, standard deviation, which is represented by s, and the size, which is represented by small n, is called statics. Right? Now, what exactly is the idea? I'll just give you a simple example. Suppose I have an industry and I have given a declaration that in my industry, when I am producing, say, bulbs, so in a lot of 100, only 10 are defective. Okay, or I will say कि only 10% are defective in my whole production. On an average, only 10 are defective in my production. But now there is an audit team who will come. They will pick up a sample and they will check. Now, based on that sample, they will decide whether what I said was correct or not. So that is a rough idea of sampling. Now, what exactly it is, that I will tell you. Now, basically, sampling is a process of selecting sample. And the next thing which you need to understand is sampling distribution. Doing question is very easy. I am just telling you a bit of theory so that you will have an idea of what exactly you are doing. Doing question is it is the easiest module and one liner or two liner solutions. Okay. Now what we do, we usually pick up different samples of different size. Okay, and find out their mean and standard deviation, etc. Now there will be change in the values. So we group characteristic according to the frequencies. The frequency distribution so generated is called sampling distribution. Right. So in a population, when I collect different samples, they have different mean and different standard deviation. So instead of that, we group them according to the frequencies. And that is called the sampling distribution. Okay. Now the next term which you need to understand is testing hypothesis. Now what is this testing hypothesis? In order to arrive at a decision regarding the population through a sample of the population, we have to make certain assumptions. And these assumptions are called hypothesis. And then we check whether our hypothesis is right or wrong. For example, when I said, suppose if I am talking a population as New Horizon College of Engineering and I am saying the average CGPA of the student is 9.2. So this is a hypothesis. Correct. So now what are the different types of hypothesis? There is one null hypothesis which is represented by H0. And there is alternate hypothesis which is represented by H1. Now what is a null hypothesis? The hypothesis which is formulated for the purpose of rejection under the assumption that it is true is called null hypothesis. and any complementary hypothesis to null hypothesis is called alternate hypothesis. Now in this sometime error comes. How error will come? Suppose there is a hypothesis which is true, but I have rejected it. I am saying, suppose I have rejected the hypothesis that CGPA of New Horizon College students is 9.2, but actually it is true. So it is an error of kind 1. Same way, if the hypothesis is false, okay, suppose I am saying CGPA of a New Horizon College student is 5, which is wrong, but by mistake in calculations, not by mistake in through calculation, because of the sample selected, I came to a conclusion that it is true. Then it is an error of type 2. So when I am rejecting the correct thing, that is type error 1, and when I am accepting the wrong thing, that is type error 2. Right? Now what is significance level? These are the words I will be using. Okay. Now what is the significance level? Let us understand that. In order to minimize both these types of error, that is error of type 1 and type 2, which I explained you, sample sizes increase. Acceptance and non-acceptance is based on sample. We know that for anything, sampling, whether I am accepting or not, depends upon the sample. So what we do, we increase the sample size. Now the probability below which leads to rejection of hypothesis is known as significance level. So we decide one level. So the probability below that level where the hypothesis will be rejected is called the significance level. This probability is conventionally fixed at 5%, 0.05, or this is also known as 95%, and other one is 1%, which is also called 0.01 or 99%. So these are the two levels we have decided. And under two-tailed test, the value of Z alpha is 2.58, is 1.96 for 5%, and Z alpha is 2.58 for 99%. Now how I am going to do the questions? First, what will be my procedure? My procedure will be like this. First, I will set up the hypothesis H0 and H1. Then I will see what is the level of significance. Okay, then I will calculate Z. And then I will compare this Z value to Z alpha. If this Z value, the absolute value of Z value is greater than Z alpha, I will reject the hypothesis. Okay, reject H0. And if this Z is less than Z alpha, I will accept the hypothesis. Correct? Now, what is a test of significance and confidence interval? The process which helps us to decide about the acceptance or rejection of the hypothesis is called test of significance. Right? So, these are the basic concepts. Now, what type of questions I will be having? See, I have two categories of samples. One is large sample and another is a small sample. Large sample is basically n is greater than or equal to 30. Small sample is obviously less than 30. Under small sample, you have t-test, you have f-test. F-test is basically a preliminary test for t-test. And we have chi-square test. Okay. Now in large sample, I have test of single mean, I have difference of mean, I have single proportion, and I have difference of proportion. So I will cover this topic in one video. I'll cover this topic in one video. Then in one video I will cover t-test, in one video I'll cover f-test, and in one video I'll cover chi-square test. So this is how I will be planning my videos. Okay. So now let us start with the single mean. Now, first of all, how you will recognize the question in exam? See, first of all, you see what is the sample size. If sample size is greater than 30, then it is definitely a large sample. Now, when you come across the questions of large sample, there will be four varieties. First, you see anywhere mean or average word is used here. If mean or average word is used, it belongs to the first two cases. Now, if there is a mean and a mean of a sample and a mean of a population, means in a question when you are reading, you are very clear there is a big collection and you are talking about a small collection of that big collection, and average is there, mean is there, then it belongs to category 1. So basically category 1 is population versus sample. When you see they are talking about two different groups, small groups. For example, now I am not talking about the college. New Horizon is a big college and I have taken your class and I am comparing CGPA. I am talking there are two sections in your college and I am talking about them. So that is called the difference of mean, where I talk about sample versus sample. Now suppose in the question there is no mean only, there is no average only, then it belongs to proportion. So now again, if there is a population versus sample, it is a single proportion. If it is a sample versus sample, it is a difference of proportion. Okay. So now let us start with the questions. Now the first category is test of single mean. This is basically population versus sample. So I'll calculate here Z as x bar minus mu upon sigma by root n. Okay. Now x bar is mean of sample. So x bar is mean of sample. Mu is mean of population. Okay. Sigma is standard deviation of population. In case the standard deviation of population is not given, in place of sigma you take S, which will be the standard deviation of sample. So they may give sometime instead of standard deviation of population, they give it for sample. So in place of sigma in this formula, you can take S. And obviously small n is the size of a sample. Correct? Now in this sometime they ask the confidence limit also. So what is a confidence limit formula? Confidence limit is x plus minus z alpha sigma upon root n. Now z alpha will depend upon in question what I have mentioned. I have mentioned 95% or 99%. Right? So this is the two formulas. First you have to remember 1 and 2. Now come for difference of mean, where you will have sample versus sample story. Now in this case the formula is z is equal to absolute value of x1 bar minus x2 bar upon under root of sigma 1 square upon n1 plus sigma 2 square upon n2. Now in this also, sometimes they give two samples and they tell different standard deviation for them. But sometimes when the samples are from the same type of population, their standard deviation is same. So that time they'll give only one standard deviation, sigma. So in place of sigma 1 also you put sigma, and in place of sigma 2 also you put sigma. Right? Now in this case also confidence limit when I speak, so confidence limit is x1 minus x2 plus minus z alpha under root of sigma 1 square upon n1 plus sigma 2 square upon n2. So now keeping these formulas in mind, let us start with the questions. As I said, you just need calculator. Doing question is very easy here. Okay, so let us start with the first question. Now try to understand gather the information, and then we will decide which formula to be applied. See, a firm manufactures resistors which are known to have resistance with standard deviation 0.02 ohms. So they are talking about one firm, right? A random sample of 64 resistors had mean resistance this. Can we conclude that the mean, see, first of all the word mean came, means it belongs to either first case or second case. right? Now they are telling there is a firm and you have picked up a sample out of it. So it is population versus sample. So now you write down the information given. When they are talking about a firm, they said the standard deviation is 0.02 ohms, means sigma is equal to 0.02 ohms. Correct? A random sample of 64 resistors means n is equal to 64. Had mean resistance 1.39 means x bar is equal to 1.39. Can we conclude that the mean resistance of resistors manufactured by the firm is 1.4 ohms, means mu is equal to 1.4. Okay, so this is the information I have gathered. Now you write null hypothesis. H0. Mu is equal to x bar. Alternate hypothesis. H1 is equal to mu is not equal to x bar. Okay. Now I'll calculate Z. What is Z? Z is absolute value of x bar minus mu upon sigma by n root n. Correct? So let me put the value. X bar is how much? 1.39 minus 1.4 upon 0.02 by root n. So what is n? Root 64. Now all of you have the calculator. Calculate it, you will find it is equal to 4. Now, in this question, they have not mentioned any significance level. So what I will do, I'll write Z is greater than, or Z is equal to 4 is greater than 1.96. So hypothesis is rejected under 5% level of significance. Okay, now Z is greater than 4 is greater than 2.58. So hypothesis is rejected under 1% of level of significance. That's it. Question done. That's the only small thing you have to do. Now come to the next question. A machine is designed so as to fill the bottles with 200 ml of a medicine. A sample. Again it is population versus sample and they are talking about mean. Right? So mu is equal to 200. N is equal to 100 bottles. And when you are measuring the content of this 100 bottles, each bottle has average 201.3 ml. Now if the standard deviation of the filling is this, means sigma is equal to 5, then test whether the machine is functioning properly. Use 5% level of significance. Correct? Now, first, null hypothesis. So, null hypothesis, you can write this sentence also. Test whether the machine is functioning properly or not. So, I will say machine is functioning properly. And if you don't understand, you can write mu is equal to x bar. And H1, machine is not working properly, or mu is not equal to x bar. It's up to you what you want to write. Now what is Z? Z is equal to absolute value of x bar minus mu upon sigma root n. So x bar is 201.3 minus 200 upon 5 and root 100. Correct? So now when I solve this, I get 2.6. Right? Now, 5% level of significance or 1% level of significance, both the cases it will be rejected for sure. So for 5% level of significance, I'll write Z is equal to 2.6 is greater than 1.96. So hypothesis is rejected under 5% level of significance. Okay, let's move to the next question. A random variable has variance 81. So understand variance is what? It is a square of standard deviation. So if variance is 81, means standard deviation is 9. Its mean is not known. 144 random observation means n is equal to 144 of variable have mean 112. So x bar is equal to 112.6. Test the hypothesis that the mean variable is, so mu is equal to 114.5. Okay, and we have to discuss both the level of significance. Now, again null hypothesis H0 is mu is equal to x bar, and alternative hypothesis is mu is not equal to x bar. Now z is equal to, so I am not writing the formula, I will just put the values. 112.6 minus 114.5 upon 9 and root 144. Okay, so the value here it is 0.281 or 0.253. Let us check. Let us check with calculator. What is the value you are getting? 2.53, I think. Okay, so let me cross check again. So I will go to home. I'll go to calculation. And then I'll check this. So I will use 112.6 minus 114.5 divided by 9 is equal to into 12. So it is 2.53. Now 2.53, z is equal to 2.53, which is less than 2.58. So hypothesis is accepted under 1% level of significance. But z is equal to 2.53 is greater than 1.96. So rejected under 5% level of significance. Okay. Now come to the next question. It is required to test the hypothesis that on an average Punjabis are 180 centimeters tall. Okay, so mu is equal to 180. For this, a random sample of 50 Punjabis is considered. So n is equal to 50. The mean height of this is found to be 178. So x bar is 178.9 and standard deviation is given 3.3. It is given for sample, but I told you if it is given for sample, you can use it in the formula. Now I will write down the hypothesis and then apply the formula. So z is equal to x bar minus mu upon sigma into root n. Okay, so let us calculate this. So now I have 178.9 minus 180 is equal to this, then multiply root of 50 is this divided by 3.3. So I got 2.35. Okay, so I got 2.35. Now under 1%, okay, under 1%, my hypothesis 1% means you have to compare right there in the same manner. Z is equal to 2.35, which is less than 2.58. So accepted under 1% level of significance. Z is equal to 2.35, which is greater than 1.96. So rejected under 5% level of significance. See, this level of significance thing I have explained you here. See this one. So 5% means 1.96. 1% means or 99% means 2.58. So I hope I am not doing the reverse. Okay, 2.58 is always 1%, correct. Right? So now let's move to the next question. Okay. It has been found from the past experience that the mean breaking strength of a particular brand of thread is this, with standard deviation this. Recently a sample of 36 pieces, okay, so it's a very direct question. Mu is equal to 275.6, sigma is equal to 39.7, n is equal to 36, and x bar is equal to 253.2. So now fix your hypothesis first. Okay. So hypothesis you can write thread has an inferior like that, or you can just write mu is equal to x bar. Okay. Now calculate your z. So this is fixed. If you remember the formula of z, questions are very easy. So z is equal to x bar minus mu upon sigma root n. Right. So z is equal to x bar 253.2 minus 275.6, since it is the absolute value. So if you do mu minus x bar also, it's perfectly okay, because you have to consider only the magnitude, right? 39.7 and root n means 36. So let us solve this now. So I have 253.2 minus 275.6 divided by 39.7 is equal to into 6. So I got 3.3853. So under both the level of significance, my hypothesis is rejected, right? Because it is greater than 1.96, it is greater than 2.58 also. Now come to the next question. The means of simple samples. Now see, all of you pay attention. The means of simple samples means I am talking about two different samples of sizes 1000 and 2000. Means n1 is equal to 1000, n2 is equal to 2000. So it is not population versus sample, it is sample versus sample. Okay. And the means are, means x1 bar is equal to 67.5, x2 bar is equal to 68. Can these samples be regarded as drawn from the same population of standard deviation 2.5? Means one sigma is given, so sigma 1 is also 2.5, sigma 2 is also 2.5. Right? Now, since it is sample versus sample, I'll apply the another formula of z. What is that formula? Z is equal to absolute value of x1 bar minus x2 bar upon under root of sigma 1 square upon n1 plus sigma 2 square upon n2. Right? So now let's put the value. X1 bar is what? 67.5 minus 68 upon under root of sigma 1 square means 2.5 square upon n1, that is 1000. Okay. Then plus sigma 2 square means 2.5 square upon 2000. And I should talk about the absolute value of this. So now pause the video and calculate this. So this will be equal to 5.16. Now under both the level of significance, the hypothesis is rejected. So you have to write z is equal to 5.16, which is greater than 1.96. So rejected under 5%, and it is greater than 2.58. So it is rejected under 1% hypothesis level of significance. Okay. So this is how you have to do the question. Let's move to the next question. It is known that IQ of boys has standard deviation 10 and that IQ of girls has standard deviation 12. So again they are talking about two samples. One is for boys and one is for girls. Right? So now IQ of boys is standard deviation means sigma 1 is equal to 10 and sigma 2 is equal to 12. The mean IQ of 200 random boys means N1 is 200 and X1 bar is equal to 99. And mean IQ of 300 girls means N2 is equal to 300 and X2 bar is equal to 97. Now, can it be concluded that on an average boys and girls have the same IQ? So, I'll fix the null hypothesis. What is my null hypothesis? H0 is equal to average IQ of boys and girls is same. So, average IQ of boys and girls is same. Okay. What is alternative hypothesis? Average IQ of boys and girls is not same. Okay. Or you can write x1 bar is equal to x2 bar. X1 bar is not equal to x2 bar. Simple. Now you will calculate z. Now z is what? See, it's just formula based. Remember the formula, put the value. So x1 bar minus x2 bar means 99 minus 97 upon under root of sigma 1 square means 10 square upon n1, that is 200, plus sigma 2 square means 12 square upon n2. So now calculate this. So you will get 2.02. So under what you will write, z is equal to 2.020, which is greater than 1.96. So rejected under 5% level of significance or 95% level of significance, and z is equal to 2.020 is less than 2.58. So it is accepted under 1% level of significance or 99% of significance, right? Let's move to the next question. Certain dose of pain reliever when administered to each of 32 women patients, the average duration of pain relief was 3.5 hours. The same dose when administered to 36 male patients. Now again two samples are there. Okay. Now the first sample N1 is equal to 32. X1 bar is equal to 3.5. Okay. For men, N2 is equal to 36 and X2 bar is equal to 4. And standard deviation, sigma is equal to 0.5. So same thing, first write down the null hypothesis, then calculate z. So what is z? 32 minus 36 upon under root of, wow, I did wrong. So 3.5 minus 4 upon under root of sigma 1 square, that is 0.5 square upon 32 plus 0.5 square upon 36, right? So what is the value of z in this case? So 3.5 minus 4, it is 4.11. So under both the hypothesis, this will be rejected for sure. Correct? So this is, we are done with the sampling when it is concerned about the large sample, single mean and difference of mean. So in my next video, I will be discussing about proportion. I hope you like the video. So share the video and subscribe the channel, which is most important for me. So do it for me, subscribe the channel so that you will get a notification whenever I'll upload a new video. Thank you.